Parabola. Parabola is a set of all points in a plane that are equidistant from the fixed point F, called the focus, and the fixed line L, called the directrix. In this section, we'll pay special attention to parabola with the vertex at the origin and that have the vertical or horizontal axis of symmetry. So if you look at this graph of the parabola, we have the vertex is at 0, 0. So when we're looking at this, this is our xy plane. So there's a point inside the parabola called the focus. The distance from the focus to any point on the parabola is the same as the distance from that point to the directric. So the directric is the line L that is below the x-axis. Okay. The parabola with the equation is x squared equals 4py is called a parabola with the following property. It has the vertex at 0, 0, the focus at 0p, the directric at y equals negative b, and the focal diameter equal to 2p. Okay, so that is this distance, that is the focal diameter. Excuse me, I'm taking that back. The focal diameter is 4p instead of 2p. So 4p, that is the distance between the 2 points that is going through the focus, where the focus is the center of the focal diameter. Okay. The parabola open upward if p is greater than 0, downward if p is less than 0. So given x squared equals 12x, we want to find the focus, directric, and local diameter of the parabola. Okay, so we will rewrite the equation in terms of 4py. So this is 12 equals 4 times 3y. This telling us y is equal to 3. Excuse me, p is equal to 3. So then this parabola have the vertex at 0, 0, the focus equal to 0, 3, the directric is y equal negative 3, and the focus diameter, focal diameter, (4p), that is equal to 12. So let's go ahead and sketch the graph based on the information that we have. So the vertex is at 0, 0. The focus at 0, 3. So let's label this. Here's F at 0, 3. Here's vertex. And then we have the directric that is y equal negative 3. So this is the line of the directric. Y equal negative 3. So since the focus diameter equal to 12, which means each of this distance here, the distance between F to the point on the parabola is 6 each way. And because P is positive, we have the parabola open up. So this is the parabola that we are looking at. Next then, we want to find an equation of parabola that have its vertex as the origin and then satisfy the given condition. The focus on the negative y-axis. If the focus is on the negative y-axis, this telling you that the parabola is open down and P is negative. Okay. And if the focus is 6 units away from the directric, if the focus is 6 units away from the directric, so take a look at this, let's make a rough sketch of it. If the focus is 6 units away from the directric, this is the line to directric, y equal negative p. and this is the focus point 0, negative p. If this distance here is 6 units, this distance here is 3, and this is 3. So this telling us that p equal to negative 3. So then p is equal to negative 3. So our parabola is x squared equal to 4 times negative 3y, and that is negative 12y. Let's take a look at the next type where the parabola open to the left or the right. The graph of the equation y squared equal 4px is the parabola with the following property. The vertex is 0, 0. The focus is p0. So note that because the parabola open left and right, the focus is now on the x-axis instead of on the y-axis as usual. And we have the directric of the vertical line x equal negative p. The parabola will open to the right if p is greater than 0 and to the left if p is less than 0. We can use the coordinate of the focus to estimate the width of the parabola when sketching this graph. The line segment that runs to the focus perpendicular to the axis with the end point of the parabola is called the lattice rectum, and its length is the focal diameter of the parabola. So we can find the diameter of the focal diameter of the parabola and use that to sketch the graph. Okay. So given y squared equals 16x, we want to find the focus, directric, and focal diameter of the parabola. So I go ahead and will rewrite this as y squared equals 4 times 4x. This then implies p equals 4. Because p is equal 4, so p is equal 4, and that is greater than 0. This telling us the parabola is open to the right. The focus is equal to 4, 0, and the directric is the line y equal to negative 4. The focal diameter equal to 4p, that is 4 times 4 equal to 16. So let's start with the graph. We have the vertex is 0, 0, the focus equal 4, equal to 4, 0, and the directric is the line x equal to negative 4. So this is our directric, x equal to negative 4. Now we will use the focal diameter to find the next point on the graph. Since it is 16, this means that the next point is 8 units away from the focus point. So 2, 4, 6, 8, this is one point. 2, 4, 6, 8, this is the other. So here is our parabola that is open to the right. And this is y squared equals 16x. We want to find an equation of the parabola that have its vertex as the origin and satisfy the given condition. The focus is on the positive x-axis. This telling us that p is positive. 2 units away from the directric. If it's 2 units away from the directric, with this telling us that p is equal to positive 1. Yeah. So then we can write the equation as y squared equals 4 times 1x, that is equal 4x. Let's take a look at an application problem. So what do we want to know about algebra for, right? A parabola have an have an important property that make them useful as the reflector for lamp and telescope. Light from a source that play at the focus of a surface with parabolic cross-section will be reflected in such a way that it travels parallel to the axis of the parabola. Thus, the parabolic mirror reflects the light into the beam of parallel array. Conversely, light approaching the reflector in an array parallel to its axis symmetric to the center of the focus. Okay. So the next example say a searchlight have a parabolic reflector that form a bowl which is 12 inches wide from rim to rim, 12 inches wide from rim to rim, and 8 inches deep. If the filament of the light bulb is located at the focus, how far from the vertex of the reflector is it? So let's take a look let's try to draw a picture. So let's see, you have a bowl-shaped kind of light. And it said that it is 12 inches wide, okay, from rim to rim. So from this distance to here, this is 12 inches wide. And it's 8 inches deep. So this distance here is 8 inches. Okay, so let's go ahead and translate this into a coordinate plane to see how this works. So we have a parabola. Okay, and from the lowest point of the parabola to this one point that we know, this is 12 inches wide. So if this whole distance is 12 inches wide, this distance here is 6, right? And from here to here, that is 8. So by looking at this, I know this equation is of the form x squared equal to 4py. Think of this as the parabola that have vertex at 0, 0 and pass through the point 6, 8. Okay. Now that I have a point, I can find p. So here is x, here's y. We'll plug this into this equation. So x squared equal to 4p times y. So then 36 equal to 4 equal 32p. This means p equal 36 divided by 32. Simplify this by 4. So this is 9 over 8. So then so how far from if the filament of the light bulb is located at the focus, so this is where the focus is. How far from the vertex of the reflector, so we are looking for p, right? So this is the distance that we're looking for. And so that is p equal to 9 over 8. Now take a look at the second problem. A satellite dish is shaped like a paraboloid of revolution. This meant that it can be formed by rotating a parabola around the axis of symmetry. The receiver is to be located at the focus. Okay, so here you get here's the cross section of the satellite. If the dish is 12 feet across, okay, 12 feet across, and open at its opening and 4 feet deep at its center, and here's 4 feet deep. And we want to find the location of the focus. So similarly to the problem that we have earlier, I can translate this into an XY coordinate plane. If the diameter here is 12 feet across the opening, which means this distance here is 6. Okay. So this is the parabola of the form x squared equal to 4py, and it have vertex at 0, 0 and pass through one point. For 6. Okay. I can solve for P, that is the location of the reflector. So then 4 squared equal to 4p times 6. 16 equal 4p times 16 equal 24p. P equals 16 divided by 24. Simplify this by 8. So this is a 2/3 feet away from the bottom of the satellite.